Good morning, guys. This is Anjani Kumar, Electrical Department, Newton's Group of Institutions. In the last class, we'll discuss about basic electrical machines, right? How each and every electrical machine will work. We'll start it, right? So in that, we successfully completed the DC generator concept. You know what is DC generator? So generator which converts mechanical energy into electrical energy. How it will work? We have a magnet and you have a conductor, right? So according to the Faraday's law of electromagnetic induction, you should require a change in flux to generate the voltage. So how the change in flux will be produced there? You need to rotate at least once. At least one thing you should rotate, either conductor or else a magnet should rotate in order to change in the flux. You know everything, right? I place a conductor between a permanent magnet. So in a permanent magnet we'll get a main field flux from north pole to south pole. I placed a conductor, right? So at least one should rotate to get the change in flux. See, if you rotate a conductor, you will get what type of machines? DC machines. If you rotate a magnet, magnet means magnetic field, also you will get a change in flux. Those type of machines, we can call it as a AC machine. That is a very, very important question. So what happened? If you give a mechanical input to the conductor, what happened? The conductor starts rotating. Mechanical means rotation. The conductor starts rotating. So when a conductor starts rotating, it will cut the main field flux in different position. In a perpendicular position, there is no flux, there is no EMF. Again, keep on increasing, right? On the main field axis, you are getting a maximum EMF, right? So in this way, you will get AC flow. So, but the machines are DC machines. So we require a DC. How it will convert? With the help of a commutator, it will convert that AC into DC. Do you know how the commutator will work? So commutator will work on the principle of current reversal. You know everything. That's acts as a rectifier. You know that will act as a rectifier. Alright. So what is the generated EMF equation? You know you are giving mechanical input. You are generating voltage. That means generating EMF. That EMF we can call it as a E. That EMF will be sent to the load. So what is the load voltage you are getting? Plus or minus. That means V. So what is the equation? E is equal to V plus IA RA. This is the generator equation. So what we can call it as a V? V is nothing but a load voltage. What is IA RA means? RA is nothing but internal resistance of a generator. So each and every machine that has some internal resistance that is very less to restrict that machine from high currents. IA means armature current, which will be sent to the load. Alright, E is equal to V plus IA RA. How it will work? You know the equivalent circuit of the generator. From that you will get the equation, right? You don't need to by heart. So what is the EMF equation? Zn P pi by 68. You know everything. The derivation also you know. And after that we'll discuss about excitation. So why we need to excite a magnet? So definitely if you need to excite a magnet in order to get the more flux. So if you are getting more flux means you are getting more voltages. So it depends on excitation. Excitation means you are giving voltage to a magnet. So magnets gets heated. It will generate more flux. So it will get more flux, more voltages. That is the concept. So it depends on excitation. My generator classified into separately excited machine, self-excited machine. So what is meant by separately excited machine? You are giving your field excited by a separate DC source. Self-excited means in the generator itself. Generator developing a voltage now. So with that voltage, you are exciting your field. So that is called self-excited generators. Alright. After that, two concept is that you know about internal characteristics, external characteristics, you know everything. So that's not that much important than the basic things, right? After that, so what is the concept of critical speed and critical resistance? This is very, very important question. So the concept of critical speed and critical resistance will get in shunt machines, self-excited shunt machines. So separately excited, you have a DC source, you will exit the DC source, will get the generator flux, flux will cut the automatically rotating mechanical input, the conductor starts rotating, will cut the flux, will get the EMF. But what about a self-excited EMF? Now I have a shunt generator. So generator, magnetic field which is connected parallel with the generator. So it's a self-excited machine. See what happened. So self-excited machine means my field is going to be excited with the help of the whatever the voltage that is generated by the generator itself. At the time of starting, in a shunt generator, you have any voltage, you have any current, no voltage, no current. My field won't excited. So my field won't excited means there is no voltage. But my field is having north pole and south pole. It have a minimum flux. So with this flux, we have small voltages. So with this small voltage, small current will be developed. Some current will flow to the load, some current will flow to the shunt field winding. So with that current, my field is going to be excited. So again, it will generate more flux, more voltage, more current, and again some current flow to the load and some current flow to the field. So keep on exciting the field. So that means my voltage is developing more and more. So we are generating a field is going to be excited means more flux generated, more voltage generated, some current will flow to the load, some current will flow to the shunt winding. So maximum speed at which you are getting a voltage, నాకు రిక్వైర్డ్ వోల్టేజ్ రావాలి, ఏ స్పీడ్లో వస్తుంది, దట్ స్పీడ్ వీ కెన్ కాల్ ఇట్ యాజ్ ఏ క్రిటికల్ స్పీడ్. Alright, so keep on increasing your flux excited. So keep on speed increases, keep on voltage increases. Some voltage will flow to the load, some current will flow to the shunt machine. Alright, so నాకు లోడ్ వచ్చేసి 10 to 15 volts కావాలి. See, for example, I'll clearly explain. I have a load. I require 10 to 15 volts. Alright, I connected a machine. Shunt field winding is connected. So shunt excite చేయాలంటే definitely I don't have a minimum voltage. I don't have any voltage. So at the time of starting, shunt field which is having a minimum flux north pole south pole excite చేయక ముందు కూడా కొన్ని ఫ్లక్స్ ఉంటాయి. నార్త్ నుంచి సౌత్కి కొన్ని మ్యాగ్నెట్స్ పక్కన పెట్టామంటే డెఫినెట్లీ విల్ హ్యావ్ సమ్ ఫ్లక్స్. సో విత్ దట్ ఫ్లక్స్ some speed is gained and some voltage is developed, small voltage, right? That voltage generate the current and then current will flow to the load. నాకు కావాల్సిన కరెంట్ వస్తుందా రావటంలా. Some current will flow through the field winding. So with that I have a current in the field. That means the field get excited. More flux is generated. So again this flux will create speed and develop the voltage, right? Some more current will be flow. So that current, some current will flow to the load and some current will flow to the field winding. నాకు కావాల్సిన కరెంట్ వచ్చిందా రావటంలా. So again keep on increasing. So the maximum speed is at which the required voltage will get, that speed we can call it as a critical speed. That is very, very important question. Now what is a critical resistance? Now keep on increasing the voltage, keep on increasing the current. Some current will flow through the load and some current will flow to the shunt field winding. ఇట్లా కరెంట్ పోతూ ఉంది. సో నా మ్యాగ్నెట్లో కరెంట్ వెళ్తూ ఉంది. సో ద మ్యాక్సిమం కరెంట్, సో field is nothing but a resistance, a twisted conductor, right? So each and every conductor that it has a resistance. So the maximum resistance, that means కొంత కరెంట్ వెళ్ళిపోయింది అనుకో, బాగా ఎక్కువ కరెంట్ వెళ్ళిపోయింది అనుకో, ఫీల్డ్ ఏమవుతుంది, డిమాగ్నటైజ్ అవుతుంది, సాచురేట్ అవుతుంది. సో ఫీల్డ్ సాచురేట్ అయింది అనుకో, ఇస్ దర్ ఎనీ ఫ్లక్స్? No flux. Is there any EMF? no EMF. So the maximum resistance at which my voltage is 0, my maximum field winding resistance at which there is no rotation, no EMF, the maximum resistance at which the voltage is 0, we can call it as a critical resistance. Isn't it? You got clear? I don't have any blackboard to explain because you got all this information in your past semester, so that's why I'll remind you, right? So what are the concepts that you will get? So I think you understand what is a critical speed and what is a critical resistance, right? So critical speed means the maximum speed, the speed at which you will get your required voltage. It's a build-up voltage. That speed we can call it as a critical speed. What is the critical resistance? The maximum resistance at which my voltage is 0. Maximum resistance వచ్చేసిందనుకో, automatically what happens? Field gets demagnetized. When the field gets demagnetized, is there any flux? There is no flux. How you can generate the voltage? The voltage is 0. Alright. So this is about generator. Now we'll go for motor. So what is a motor? You know about what is a motor? Which converts electrical energy into mechanical energy. So same concept. So input is electrical, output is mechanical. Similarly, I have a permanent magnet. North pole to south pole, you are getting a flux, and I place a conductor. At least one should do it. We'll discuss. Alright. Now, so what is my input? Electrical energy is my input. Now I am giving current to a conductor because you are giving electrical, right? Electrical energy you are getting rotation. So then your motor principle is over, right? You are giving electrical energy to the conductor. So magnetic field undi, field constant ga undi. So current పంపించావు conductor gunda. So what happened? See Ampere's law said. What Ampere's law said? When current flows to the conductor, what happened? There will be a magnetic field will be produced. Right? See, north pole is there, south pole is there, flux will be there, conductor place చేసావు, conductor గుండా current పోతుంది. So when the conductor గుండా current పోతుంది అంటే definitely there will be a magnetic field around the conductor. Right? So if the current flow like this, according to Fleming's law, if the current flow through the conductor like this, the flux direction will be like this. Right? Already main flux direction will be there, and conductor flows. The Fleming's law, conductor చుట్టూ magnetic field will be created. So you know the direction of a magnetic field. So if you see around the top of the conductor, the main magnetic field and conductor magnetic field both are AD, and below both are opposing. That means in the top of the conductor you are getting more flux, and at bottom of conductor you are getting less flux. That means you are getting more flux on the top, you are getting less flux on the top. Less flux means both are cancelled out. Automatically what happened? The pressure, the force will be developed. Due to that force, my conductor starts moving. Got it na? I'm a person, right? ఒక బస్తా నా మీద వేసారనుకో, డెఫినెట్లీ ఐ విల్ మూవ్, రైట్? 2 బస్తాలు వేసారనుకో, ఆటోమేటిక్లీ ఐ విల్ మూవ్, రైట్? Move, keep on moving, right? So that means you are giving electrical energy, my conductor starts rotating, you are getting mechanical energy, so that the motor principle is over. So this is for one conductor. And a motor, according to my rotation, according to your choice, number of conductors is that. That means keep on rotating. So you're giving electrical, you're getting mechanical. That means you are getting force. Due to that force, at the torque will be down. Due to the torque, the conductor starts rotating. So what is a torque? Linear motion means linear conductor, which is a rotation. It makes as a rotation. I think you people understand, but I don't have any blackboard, right? So just remind it. See, what is the definition of a motor? When current carrying conductor placed in a magnetic field, it experiences the force. So due to this force, the torque will be created. So due to the torque, my conductor starts rotation. Alright, now what is a voltage equation? What is a voltage equation? What is a voltage equation from a motor? You'll get. So what is a voltage equation? Motor means you are giving electrical energy. Voltage V that you are giving. Some current will flow through the motor and you are getting mechanical energy. Now tell me the equation.